Hello everyone, welcome back to our sessions. In this video, we are going to discuss about applications of LCM and HCF. Already in the last video, we discussed some of the applications of LCM and HCF. And in this video, we are going to cover remaining set of questions on applications of LCM and HCF. Okay, before going to solve questions on another applications of LCM and HCF, okay, I wanted to discuss about 6 important applications of LCM and HCF, which are most important applications of LCM and HCF. Here we go the 6 applications of LCM and HCF. We'll just quick revise what are these 6 applications. First, if you observe the first one, find the greatest number that will exactly divide ABC. Okay, means we need to calculate HCF of ABC. Okay, this is very quite a common application. Okay, similarly for LCM, we'll just go with the process. Okay, LCM, find the least number which is exactly divisible by ABC, means we need to calculate LCM of ABC. Okay, next, find the greatest number that will divide ABC, leaves XYZ reminders. Okay, means when we divide a number with 3 numbers and we are getting 3 different reminders, at that time we need to calculate highest common factor of A minus X. Here they will give you values of A, B, C and XYZ. Okay, A minus X, B minus Y, C minus Z. Okay, so it's better if you remember or if you make a note of these 6 applications. Most probably if they wants to give applications of LCM and HCF questions, either the question will come from the previous video question type of questions or else from this type of questions. Okay, find the greatest number which when it divides ABC leaves same reminder. Okay, remember here what's the difference between second question and third question? Means in the second question 3 different reminders, third question same reminder. If you are getting same reminder, whatever it is, either 1 2 3 and so on, okay, but it should be same. Okay, highest common factor of A minus B, B minus C, C minus A. Okay, actually there will be a proof how we are taking this A minus B, B minus C and C minus A. Okay, we don't have time to discuss all these proofs and all. You just remember how we can take it as HCF of the given values. Now fifth one, find the least number when it is divided by ABC, leaves same reminder. Okay, LCM applications is more important here. Okay, when it is same reminder, just calculate LCM of the given numbers plus reminder. That will gives your answer. Okay, for the further questions, when we are solving questions, I will explain you clearly about these applications by taking one example. Okay, as of now, you just remember these 6 applications. What if here 3 different reminders? That says the 6th application. Okay, 3 different reminders. Okay, at that time, here 3 different reminders, we just need to check whether A minus X, B minus Y, C minus Z. Okay, difference is constant, that will be assuming it as K. So LCM of ABC minus the difference. Okay, minus the difference. Here, if it is same reminder, add the reminder. If it is the same, I mean different reminders, subtract that particular difference. Okay, these are 6 important applications of LCM and HCF. Okay, it's better if you make a note or it's better if you remember all these 6 applications, which is quite easy. And based on this, we are going to solve questions. Okay, already we discussed 3 videos on LCM shortcuts, HCF shortcuts, as well as applications of LCM and HCF. Okay, and this is the question. What is the least number which when divided by 8, 9, 12, 15 gives 1 as reminder? Okay, now for this case, okay, actually if you observe the previous applications, that question will fall on 5th one. Okay, that question fall on 5th application. Now here what will be the approach? What I said, LCM of 8, 9, 12, 15 plus reminder is 1. This is what final answer. If you calculate this, okay, that will be one of your options. Okay, quite simple. But here the main important thing is Okay, how you are going to calculate LCM of 8, 9, 12 and 15. Okay, LCM of 8, 9, 12 and 15. Now I will just explain you one simple example. Okay, simple example. Let's consider 10 comma 15. Okay, when I divide, okay, the least number, when I divided by 10 and 15, I'm getting remainder as 2. Let us consider I'm getting remainder 2. Okay, when I divide a number with 10 and 15, I'm getting remainder as 2. Okay, the same question I have just modified as with simple values to make you understand. Now what is the process here? LCM of 10 comma 15 plus 2, correct? What is LCM of 10 comma 15? 30. 30 plus 2 is 32. If you want, you can cross check with that. Answer is 32. Now we'll just go with the question again. 32 divided by, what's the question? Find the least number which when divided by 10 and 15. Now when I divide 32 by 10, what is the remainder? Remainder is 2, correct? When I divide 32 divided by 15, what's the remainder? Remainder is 2. Is that the condition satisfied? When I divide the number with 10 and 15, I should get the same remainder, means 2. Okay, so here also the same thing. If you calculate LCM plus if you add 1, that will be your answer. Any one of these answer, either it may be option C, either it may be option D, either it may be option B or option A, correct? So what I'm trying to say that is, don't waste time to calculate LCM of 8, 9, 12 and 15. Now if you recall the previous video, what we discussed and how we solve of LCM. Now here 179. Okay, now assume that, okay, here we have added 1 to get answer, right? Now I'm removing 1. Okay, it is 178 and it is 180 and it is 358 and it is 360. Why I have removed means, after adding 1 to the LCM, this is our option. Now if I remove 1, now these values should be exactly divisible by 8, 9, 12, 15, right? Now we'll cross check with divisibility rule. Okay, now we'll cross check with divisibility rule. Here what are the numbers we have? 12. What is the divisible? Whichever number you want, you can consider. 12. Divisibility rule of 12 is 4 and 3. Okay, now 3 divisibility rule is sum. Okay, here 1 plus 7 is 8, 8 plus 8 is 16, 16 not divisible, so option A not satisfied. 180. Okay, 180 is divisible, but here one more number we have 8. What is divisibility rule of 8? We need to cross check with 180 divided by 8. 180 divided by 8 means it is not satisfied. Why? Because 180 is not exactly divisible by 8. Option B eliminated. Next, here 358. Now 358 will cross check with any other value if you want. Okay, here it is. Let's check with 4. 358. 4 means last two digits. 58. 58 is not divisible by 4. Okay, so 360. 360 means already 3 options not satisfied. For sure this option will be our answer. Answer is 361. Okay, this is just for our reference. Okay, we are checking with divisibility rule, right? Because most of the students, by looking at the previous video, what they will make mistake is, they will directly check options. Okay, whatever the options given, 179, 181, 359 and 361, they will try to check with divisibility rule of 8, 9, 12 and 15. We are not supposed to check divisibility rule for given options. We need to subtract -1, because here they have clearly given that it will leaves remainder 1. Okay, this is the simple logic that you need to understand. Okay, and I hope you all are clear with this question. So we'll try to go with next one. Okay, if you observe this question, okay, can you guess like this question fall on which category? I mean, which application? What is the least number which when divided by 20, which when divided by, here I'm just writing, which when divided by 20, 25, 35, 40 leaves remainder, okay, 14, 19, 29 and 34. Okay, if you observe the previous applications, can you see the sixth application? Sixth application, find the least number which when divided by ABC leaves XYZ. Now LCM of ABC, we need to find LCM of ABC minus K. What is mean by K? Difference. Difference is A minus X, B minus Y, C minus Z. Difference is same. Now if you observe this question, what is the difference here? Difference is 6. What's the difference here? 6. And here also it is 6. And 30 minus 40 minus 34, 6. So we have the value of k. What is the value of k? K is equals to 6. That's it. Now we need to find LCM of 20 comma 25 comma 35 comma 40 minus k, which will gives you any one of these option. Means here we are calculating LCM of the given values minus k minus 6, okay, will gives you answer which is there in one of the given options. Now what I'm trying to say that is, here I'm not going to calculate LCM of 20, 25, 35, 40. What I'm trying to do is, I will take options. Okay, I will take options. Now I will subtract here. Actually, after subtracted, I got answer. Now I will add 6 to the given options to get LCM. Very simple. Now I will add 6. This will become 1394 plus 6 will become 1400. Correct? Okay, 1404 plus 6 will become 1410. And this will become 1412. And this will become 1670. And I hope you all are clear how I am writing this. Okay, now I have added 6. Now you need to check with whether these numbers are divisible by these given values 20, 25, 35, 40. Very simple. Okay, now you know the divisibility rules. Okay, what is the divisibility rule of 20? It should satisfy with 4 and 5. Now just by looking at the value, okay, just by looking at the value, you can eliminate some options. Correct? Okay, you can eliminate some options. Okay, what are those options that you can eliminate here? Okay, divisibility rule of 5 is the number should ends with either 0 or 5. But option C, if you observe 14, 12, 14, 12 ends with 2. So option C cannot be my answer. Remaining all options are ends with 0. So it will satisfy with divisibility rule of 5. What is divisibility rule of 4? Okay, divisibility rule of 4 means last two numbers should divisible by, yes, 4. So here 14, 10. 14, 10 is not divisible. So option B eliminated. Okay, means because 10 is not divisible, right? Now option D, if you check 70, 70 means it is not divisible by 4. Option D also eliminated. Now which option is left out? Only option A, 1400, which is divisible by 4. But answer is not 1400. Okay, we are just going with reverse way to get answer. Okay, in a simplest way. So answer is 1349. Very simple. Okay, and I hope you all are clear with this. Now we'll move on to the next question. Which greatest number will divide 3026? Okay, now I'm trying to do it directly. Okay, and I hope you got to know how I'm doing it. Okay, 1326 and 5053. Okay, leaving remainder 11 and 13. Okay, now the greatest number which will divide 3026, 5053, leaving remainder 11 and 13. Means two different reminders. Greatest number means highest common factor we need to find. Okay, and for what highest common factor? If you observe this application, can you check with second application? Find the greatest number which when divided by A, B, C leaves three different reminders. Here what we are doing for this approach, highest common factor of A minus X and B minus Y. The same thing here I am doing it in reverse way. Okay. Now what is highest common factor of? Actually the process is highest common factor of 3026 minus 11. Okay, comma 5053 minus 13. Okay, if you calculate this highest common factor of these two numbers, that will be your answer. Okay, and I hope you all are clear. Okay, but these values are 4-digit numbers, right? Okay, calculating highest common factor for 4-digit numbers, okay, it will be a bit difficult. Okay, so what I'm trying to do is, I'm not calculating highest common factor, I'm just going it in reverse. Okay, process I'm doing it as same. 1326 minus 11. What is 1326 minus 11? Okay, 3015. Correct. Now here minus 13, which is nothing but 5040. Correct. So these are the numbers. We need to calculate highest common factor of 3015 and 5040. These two numbers highest common factor. Now check with options. Okay, if any number is said to be a common factor, for sure that option should exactly, I mean these values should exactly divisible by that options. Correct. Now if you check with divisibility rules, okay, if you check with divisibility rules, okay, let me try with 30. Okay, let me try with 30. What is the divisibility rule of 30? It should satisfy with 5 and 6, correct? Okay, it should satisfy with 5 and 6, but these two numbers are, one ends with 5, one ends with 0, means it's satisfied with 5. Okay, but is it satisfying with 6? What is divisibility rule of 6? 6 means it should satisfy with 2 and 3, but here first number ends with 5. Okay, any number which ends with odd number, for sure this number is not divisible by 2, correct? So 30 is not satisfied. Okay, when 30 is not satisfied, of course 60 also not satisfied. Multiple of 30 is 60. So two options immediately eliminated without calculating any HCF. Now 15 and 45. What is divisibility rule of 15 and 45? It should satisfy with 5 and 3, and 45 it should satisfy with 9 and 5. Okay, 9, 5 times is 45. So we'll check with already 5 satisfied and 3. Okay, sum of the digits here, here the sum of the digits is 9, here the sum of digits is 9. So it's satisfied for 5, it's satisfied for 3, and also it's satisfied for 9 and 5. So two options satisfied. Okay, 15 satisfied, 45 satisfied. But what actually they're asking in the question, which greatest number will divide, means highest common factor out of 15 and 45, which is highest common factor, highest factor, both satisfied, but highest number is 45. So option A eliminated, that's it. Okay, so option C 45 is correct. Now we'll move on to the next question. The smallest number which is divisible by 12, 15, 20 and is a perfect square. Okay, very simple here. Direct question they have given without any confusions. They're talking about, we here the given options, all given options. If you observe option A, B, C, all perfect squares. Okay, am I clear? So which perfect square, which smallest perfect square which is divisible by 12, 15 and 20? If any number is exactly divisible by 12, 15 and 20 without leaving any reminder, for sure that divisibility rule should get satisfied, correct? So what is the divisibility rule of 12? It is 4 and 3. Okay, now can you check whether it is divisible by 3 or not? Now we'll check with 3. Okay, immediately option C eliminated, because what is the sum of digits? 7. Is that 7 divisible by 3? No. Okay, now similarly, which option can be eliminated? Option A eliminated. Why? Because sum of digits is 4. 4 is not divisible by 3. So answer will be either 900 or 3600. Now we'll cross check with remaining divisibility rules. Okay, now we'll check with 4. 4 satisfied. Why? Because two zeros, 4 satisfied, 3 also satisfied. Divisibility rule of 15 is 5 and 3. Already 3 satisfied and 5 also satisfied. Why? Because ends with 0, it will divisible by 5. What is divisibility rule of 20? It should satisfy with 5 and 4. Okay, so 5 satisfied, 4 satisfied, means all these numbers, whatever the given numbers, 900 and 3600, okay, both are exactly divisible. Okay, if you check, 900 is divisible by 12, 15 and 20. 3600 also divisible by 12, 15 and 20, no doubt at all. So here what they are asking, smallest number, means we are calculating LCM here, right? Okay, what is LCM? Least common multiple. There might be different common numbers which satisfies the given values, but which value we need to consider? Least common, means here answer is 900. Okay, so directly we can consider this answer. Okay, this is how, this is some of the applications of LCM and HCF. But I suggest everyone, okay, just by keeping all this knowledge and shortcut, okay, try practicing a more number of questions on applications of LCM and HCF, so that you will get good practice on this particular topic. Okay, and I hope you enjoyed this session. Thank you everyone. Do subscribe to the channel for more videos.